Poisson's equation. Del square V is equal to minus rho V by epsilon. Poisson's equation is del square V is equal to minus rho V by epsilon, where V is the potential, rho is the charge density, and epsilon is the permeability. So this is the Poisson's equation. Del square V is equal to minus rho V by epsilon. This is Poisson's equation. If there is no charge, then the charge density rho V becomes rho V is equal to 0. If there is no charge present, then the charge density rho V becomes 0. Then the Poisson equation becomes del square V is equal to 0. Del square V is equal to 0. And this equation, del square V is equal to 0, is known as Laplace's equation. Laplace's equation. Laplace's equation. So once more, del square V is equal to minus rho V by epsilon is Poisson's equation, and del square V is equal to 0 is Laplace's equation. Then in terms of Cartesian coordinates, we can write del square V as del square V is equal to delta square V by delta x square in terms of x coordinate plus y plus z, then plus delta square V by delta y square plus what's next? Delta square V by delta z square. So in terms of Cartesian coordinate, we can write del square V is equal to delta square V by delta x square plus delta square V by delta y square plus delta square V by delta x square. Hi, next we are going to learn the topic equation of continuity. Equation of continuity. Equation of continuity, that is del dot j plus delta rho by delta t is equal to 0. The equation of continuity is del dot j plus delta rho by delta t is equal to 0, where j is the current density. J is the current density and rho is the charge density. Rho is the charge density. So this is the equation of continuity. Del dot j plus delta rho by delta t is equal to 0. If the current flow is steady, then what's the condition in this equation? If the current flow is steady, then the charge density becomes 0. Then the charge density becomes 0. That means the rate of change of charge density with respect to time. For steady current, delta rho by delta t becomes 0. For steady current, the term delta rho by delta t is equal to 0. So equation of continuity becomes del dot j is equal to 0. Del dot j is equal to 0. The equation of continuity becomes del dot j is equal to 0 when the current flow becomes steady. Then equation changes to del dot j is equal to 0. From this equation, it is clear that steady current is divergentless. Steady current is divergentless or solenoidal. Steady current is divergentless or solenoidal. That means the steady current is divergentless or solenoidal. So this is all about today's class. If you find this class is helpful to you, surely share with your friends. For getting more videos as notification, subscribe and click the bell icon. So let's see in our next class.